Now I will turn to the solution of exercise 4, and that is about the deltas. Here's the first figure where you're asked to provide the value delta 3 making you indifferent. I'm going to consider these figures by comparing with figure 4.1.1, but I'm first putting up figure 4.1.1d. And as I explained in this text below, I'm reproducing figure 4 here, but I reverse the panels. I go from down to up rather than up to down. So I start with the lowest. Another thing changed is left and right prospect have been interchanged, but no big deal, of course. We look here. The question here is which value delta 3 makes you indifferent? But if we see here, we see already the answer. Well, value alpha 3 makes you indifferent. So by that simple comparison, we can already conclude delta 3 must be alpha 3. Next question, delta 2. We're going to compare now with figure 4.1.1, but now part C. Again, left and right prospect interchanged. We know that delta 3 is alpha 3, and therefore, which value delta 2 makes you indifferent? You already see it here, value alpha 2. So there we are. Delta 2 must be alpha 2. And now it goes on like that, but you get how it works now. Again, we know that delta 2 is alpha 2, so delta 1 must be alpha 1. And finally, we know that delta 1 is alpha 1, so delta 0 must be alpha 0. So we conclude that delta are yet another way of measuring the same thing. All these questions that we saw so far, we're measuring the same thing basically. And again, it's a prediction then that the deltas will be equal to the alphas, an empirical prediction that may be violated. This here is a bit different nature than the thing we saw so far, because in the reasonings here, I did not use expected utility. I only used common sense in a way. In fact, mathematically speaking, I use strict monotonicity. If one thing is the other thing with one amount is strictly increased, it can't be equivalent. That's why delta 3 has to be alpha 3 and so on. And I use transitivity. So, but very basic conditions, common sense are tested. So you think this is much more elementary, and empirically this should be satisfied. Almost every theory assumes the condition I just said. So if they are violated, we're in big trouble. Well, you can already guess what's happening. Empirically, we find big violations here. The deltas are usually much bigger than the alphas systematically. So that's quite some violation of the theory. And then you see that apparently very fundamental properties are violated. And that's a bit of troublesome and can be depressing. In a way, it is depressing. What should we do about it? Later in this course, I will introduce prospect theory, which is meant to cure violations of expected utility. And some of the violations that we saw before and we'll see after will be cured by prospect theory. But this violation not. This is so fundamental. So in a way, this is a depressing finding that we have here. And you may wonder, why are we at all studying this whole field? Why are we introducing a theory if we know beforehand it is wrong? But the point is, getting good theories here is very important. Maybe you remember from the medical example, measuring quality of life life with no voice was the crucial decisive variable in what the best decision is. That happens in many situations. It's very important that we can measure subjective taste and preferences of human beings. And in a way, if you can measure utilities in a proper manner, it's like Holy Grail. You can answer all questions in life in a way. So it's very important. So therefore, even if we know there are big problems, we know we just have to do however good or bad it is, the best thing we can do, that is what we have to do. And there are so many things that we don't understand. Still, we know already with every theory it will be violated. We have to live with that. We only can do the best we can. So that's a bit of depressing, but it's how it is. And so now I'm going to stop the recording here. Next exercise will be a next recording.